how to find the characteristic equation, how to find the roots of the characteristic equation, and how we are able to get the eigen vector or characteristic vectors. Okay, so let us try some more examples based on this. So I hope you are able to see the Jamboard. Yeah.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So let's have the matrix. Okay, and we want to find the eigenvalues and eigenvectors of this matrix. So we have the question. All of you are able to see this?
Yes, sir.
Yes, sir.
Okay, so we have to find the eigenvalues and eigenvectors of this matrix. Okay, so let's go for the solution. Okay, so we go with the solution. Let A is equal to. Okay, so we have the matrix. Write the entries carefully. So -2, 5, 4, 5, 7, 5, 4, 5, -2. Okay, so this be the given matrix. So what is the first step that we do?
Find the determinant.
Yes, so consider determinant of A. So we have -2, 5, 4, 5, 4, 7, 5, 5, -2. So we have to find the determinant of this. So calculate the determinant. Then we have characteristic equation of A as what we have here. So this is determinant of A minus lambda I equal to 0. Yeah, what is the value of determinant? Have we calculated the value of determinant? Any one of you have calculated?
210.
What's that?
210.
210. 210.
Sir, I'm
What
getting
about
216.
Please be careful, calculate it properly, use your calculator. So give me the correct answer. Yes. How many of you got 210 or 206?
Sir, it's 216.
The third answer, then 216.
208.
210, 206, 218, 216.
216.
We are getting 4 different answers. So please use your calculator and then get this. What do you have?
216, sir.
216, sir.
216.
All of you are getting 216?
Yes, sir.
Yes, sir.
Okay, so this is going to be 216.
216.
I hope there is no chance for any confusion or any doubt now. All of you are getting 216? Yes. Okay. So we have the characteristic equation as determinant of a minus lambda is equal to 0. Okay. So what we'll be having here, see, we have determinant minus 2 minus lambda. Okay. And you have here, this is 5 and 4. Okay. Then this is 5, 7 minus lambda, and you have 5. This is 4, 5, and minus 2 minus lambda, and this is equal to 0. Okay. So that's what we have. Then what is the shortcut we know? We know that lambda cube minus s1 lambda square, okay, plus s2 lambda minus determinant of a equal to 0. Okay. So that's what we have. Now let us apply this. So we have lambda cube minus s1. So s1 is minus 2 plus 7 minus 2 lambda square plus, then for lambda, okay, so what you'll be having, so we have for this element the minor is 7 5 5 minus 2, then the next minor is for this element, so it is minus 2 4 4 minus 2, and for this element the minor is minus 2 5 5 7. Okay, so tell me what is the value of this? What is the value of this you will be having? This is minus 14
39.
minus 25.
Minus
This is going to be minus 39. Okay, for this what will be having? 4 minus 16. So this is, what is the value? What is the value of this minor?
minus 12.
Minus 12.
Minus 12. Yes. For this, what will be having? Minus 14 minus 25. So again it is minus 39. And this is lambda and minus the value of the determinant. So it is going to be 216 and this is equal to 0. Okay. So this way we are able to get the characteristic equation. Let us simplify this. Okay. So what we have, so what you are having the sum, what is the sum for this? We have minus 2 plus 7, so it is lambda cube. What is going to be? Minus 3
3 lambda square.
correct? Okay, then this is what is the sum you will be having this one?
90.
What is that?
Sir,
Minus
3 lambda
90.
square.
This will be 80, 90. Please be careful. Okay, so 90 lambda minus 216 is equal to 0. Okay, so that's what you'll be having. Now factorize this polynomial. Okay, use your calculator and find out the roots of this equation. So what are the roots of this equation? What are the roots we have?
12 minus 3 and minus 6.
12 minus 3 and minus 6. So it will be lambda plus 3, lambda plus 6, and lambda minus 12 is equal to 0. Okay, so these are the factors we'll have. And then we can have the roots. Lambda is equal to minus 3, minus 6, and 12. So we can say the eigenvalues of A are minus 3, minus 6, and 12. Okay, so these are the eigenvalues. Now, what is our question? Our question is to find out the eigenvectors also. So we got the eigenvalues. Now we have to find out the eigenvectors. So let us try for eigenvectors. So what we'll be having for lambda is equal to minus 3. What we have? So we have remember this. This is an important step. We always have to write the equation, okay, and then put the value in this equation. Without writing this equation, we shall not go for solving directly. Okay, so what we have, minus 2, and we have minus lambda. Lambda is going to be minus 3, so this will be plus 3. 5 and 4, 5 and 4. Then this is 7 plus 3. We'll be having 5, and this is minus 2 plus 3. And here we have the components of this vector. So x1, x2, x3, and this is equal to, we'll be having this is equal to 0. Okay, so simplify this. What do you get here? So this is going to be 1, 5, 4, 5, 10, 5. Then this is 4, 5, 1. Are you getting this one? Is this okay?
Yes, sir.
Okay. So here we have 0. Now the question is, how many distinct equations you have? Honestly, can we apply Cramer's rule here? Anushri,
Three distinct equation.
3 distinct equations. So can we apply Cramer's rule?
Yes, sir.
Yes. Okay. So which 2 equations you want to consider?
First two.
First 2. Okay. So let us consider the first 2 equation. As we have 3 distinct equations here, okay, so we can consider any 2. Okay. So what we do is consider, okay, what we'll be having here, x1 plus 5x2 plus 4x3 is equal to 0. And here I can divide by 5, correct? So I can write this as x1 plus 2x2 plus x3 is equal to 0. Okay, so these are the 2 equations we have. So we can say by Cramer's rule, we have, so what we'll be having, we can write using this 2 equation, the equation of line of intersection of these 2 planes. So we can write x1, okay, equal to minus x2 equal to x3, okay. And so what is the x1 you will be having? So it will be first column we have to remove because we are considering for x1. So it is 5, 4, 2, 1. Okay, so here we have the determinant 5, 4, 2, 1. And now here, what is the determinant we will be having? 1, 1, 4, 1. Okay, so we will be having 1, 1, 4, 1. And then for x3, so what will be having? 1, 1, 5, 2. Okay, so 1, 1, 5, 2. And now it is easy to find out these determinants. So we'll be having x1. What is the value of this determinant?
Minus 50.
Minus
3.
3. So this will be 8 and this will be 5. So it is going to be minus 3. And for this one?
Minus 3.
Minus 3. And for this one?
Minus 3.
Minus 3. So can we cancel out this minus 3 throughout? Okay, so if we cancel this minus 3 throughout, then what I am able to get is x1 by 1, x2 by minus 1, and x3 by 1. So you got the first vector, and that is going to be, this is 1 minus 1, 1. So we can say is the eigenvector corresponding to eigenvalue lambda is equal to minus 3. Okay, so that's what we have. Now we consider lambda is equal to minus 6. So we have a minus lambda I into x equal to 0. Okay, so now the value of lambda is going to be minus 6. Okay, and let us have this value then. So it will be minus 2, then it will be plus 6. You will be having 5 and 4, 5 and 4, 7 plus 6, 5, 5, and this is minus 2 plus 6. So we got here x1, x2, x3, and this is equal to 0, 0, 0. Okay, so what we got here, so you can see this is going to be 4, 5, 4. Then this is 5, this is 13 and 5, and this is again 4, 5, 4. And here we got x1, x2, x3. So we have the right hand side is equal to 0. So now, Atharva, how many distinct equations we have?
Sir, 2.
How many distinct equations we have?
2.
2. Yes. So can we apply Cramer's rule?
Yes, sir.
Which two equations you want to consider?
First and second.
First, second. Okay. So let us consider first and second. So we can write here by Cramer's rule. Okay. We have. So what will be having? X1 upon. Okay. So this will be 5, 13. And this is 4, 5 equal to minus x2. And here we have, this is 4, 5, 4, 5. And this is equal to x3. What we have for x3? So this will be 4, 5, 5, 13. Okay. So can you calculate immediately what we have for x1? What is the value of this determinant? What is the value of determinant?
Minus 27.
Minus 27, right. Okay, what about this x2? This is going to be
0.
0.
0. Yes, so that's why the minus sign will not work. Now what about this one?
27.
It's going to be 27. So x3, 27. What you can cancel? Okay, so x1, 27 you can cancel, so it will be 1. This is x2, so it is 0, minus sign will not affect, so 0, and this is going to be x3 upon minus 1. Okay, so we cancelled minus 27. Remember one statement I have given you, that the first component you always take to be positive. Okay, and so we got the next vector, and so it is 1, 0, minus 1. Okay, so we can say is the eigenvector for eigenvalue lambda is equal to minus 6. Okay, so here we have to be careful that this x2 is not divided by 0. Okay, otherwise you will think that x2 is divided by 0 and then it is going to be infinity. No, x2 is not divided by 0. These are the direction ratios of the line. Okay, so these 1, 0, minus 1 are the direction ratios of the line. Okay, and so that's why it is in 0 direction. That means it is in x and z plane. Okay, so the line is in x and z plane. This y component is 0. Okay, so line is in x and z plane. Okay, that's why we have to be careful. Okay, and the equation of the line is x is equal to minus z, or we can say z is equal to minus x, like that. Okay, so this is the line. Now we have to think of next. Okay, so we have what will be having lambda is equal to 12. Then consider. Okay, we want to find the eigenvector. So what will be having a minus lambda I into x is equal to 0. So what we get here, this is going to be 12. Now it will be minus. So it is minus 14, 5, 4. And this is 5, 4. Be sure that it will affect only the diagonal elements. Okay, then this will be minus 5, 5, and you'll be having 5. And this is again going to be minus 14. Okay, so into what we'll be having here, x1, x2, x3. And this is equal to 0, 0, 0. Okay, Kunj, how many distinct equations we have? Kunj?
3.
3.
Sir, 2.
2.
3.
2 or 3, be sure. Kunj?
2.
Sir, 2, sir, 2.
2 equations. So
Two, sir.
which 2 you want to consider?
Second row.
Second and third. Okay. So we can have this second and third equation, and hence we can write directly by Cramer's rule. Okay, we have. So what you can say is we can have x1 by the determinant of this. So we'll be having minus 5, 5, 5, and minus 14. This is equal to minus x2, and determinant that is going to be 5, 4, 5, minus 14. This is equal to x3, and what the determinant we have, 5, 4. This is minus 5, and you will be having 5 here. So can you calculate these values? So what you got, the determinant corresponding to x1, the value of this determinant?
45.
45. Okay. Then what about the determinant corresponding to x2?
Minus 90.
Minus 90.
Yes.
Okay. What about the determinant corresponding to x3?
Forty-five.
45.
Okay. So what the common factor you can see that you can cancel? What is the common factor that you can see you can cancel it out?
45.
45.
So is this 1 to 1? Is that okay?
Yes,
Because
sir.
this minus will get cancelled. And so we got the third vector 1 to 1. So is the eigenvector for eigenvalue lambda equal to 12. Okay, so this way we can see that all the distinct eigenvalues have the distinct eigenvector. Okay, and in this case we have seen that there were 3 distinct values, so we have calculated the 3 eigenvectors, and the important thing that we need to observe is there is only one eigenvector corresponding to each eigenvalue. Okay, so this way we can see that for the eigenvalue we are able to find out the eigenvector. In this case we were having all distinct eigenvalues and distinct eigenvector. Is there any doubt in this question?
No, sir.
No, sir.
Okay, there is no doubt, right? Okay. So now I hope you are ready for the prerequisite test, right?